All right, so Barb asked me to do this space news, or really space and astronomy news. It's more astronomy news from 2022, and maybe a little bit about what's coming up in 2023. I can't see much of, like, if you raise your hand in the Zoom window, I can't see that. So if you have questions, I say just go ahead and interrupt me, and then I'll be good. Okay. So, and then hopefully we'll be able to answer them somehow. But Dave, you wanted to talk about the what's going on Mauna Loa. Do you want to go ahead and go first with that?
I can. I need to, should I go ahead and try to, you cannot start screen share while other participant is sharing.
Well, here's my bad planning. Go ahead and share a screen. Go for it.
Okay. I've got to figure out which one I want here. Your screen share paused.
It says you're screen sharing, but we just see a black screen.
Yeah, I don't. Okay, let me stop share. Let me restart again.
Well, it was coming. So
it was.
Yeah, it was slow tonight. Sorry.
So I clicked on the screen to share. Share screen.
Another flawless technical execution
yes.
of SkyWatchers Zoom.
What do you folks see?
We just see the Zoom call, no shared screen.
No shared screen, just a Zoom call. Well, it usually works like a chart. And I don't even see a way to stop sharing.
We saw it briefly.
Ah, there we go. Share screen. There's the screen I want to share. It's clicked, it's highlighted, share. How about that?
Wait. There it is.
There it is. Okay.
There it is.
I guess I dare not show any astro photos because we'll get into this again.
Nah, I think you should show. We'll figure it out.
So the big island of Hawaii, up here in the upper left, surrounded by light blue ocean. So the biggest mountain in the world is Mauna Loa. It's measured from the bottom of the ocean. And it has rift zones where it will erupt. The northeast is where it erupted recently. The southwest, it has in the past, and different kinds of lava come out of the two rifts. The southwest tends to be po'oihoi, which is very viscous. And in the 1950s, two lava streams headed west, cut the highway on the west coast in two different places, and it did it so quickly that it trapped motorists between the two lava flows.
Oh, geez.
The northeast rift tends to be A'a, which is slow moving. It's called A'a because if you stepped on it, you know why. It's really sharp. So this particular eruption was primarily from this northeast rift zone with, they number the particular rifts, and this one was F3, and it sent a lava flow headed down to between where Mauna Loa is and Mauna Kea is located. And that's where the Saddle Road, Daniel K. Inouye Highway crosses from one side of the island to the other, and they were worried about it crossing the highway. I was concerned primarily about what's at the end of the observatory road that was cut, and it goes up to the NOAA Observatory, where the High Altitude Observatory of NCAR has a solar observatory, and I've installed instrumentation there, and I was really concerned about that. The NOAA observatory is where CO2 measurements have been going on for decades. And the scientist Keeling plotted the sinusoidal variations of CO2 superimposed on this constant increase. And the Keeling curve is on the wall at the NOAA observatory building there. But I was really concerned that this lava flow could come back down in the direction of the observatory. It didn't. It headed towards the Saddle Road. Cutting that would be a mess because it's an hour trip across the island on the Saddle Road, and it's a 3-hour trip if you have to go around the south side. But over the last couple of days, the lava flow has slowed down so that it's no longer advancing at the tip of this flow. So it looks like it's not going to put that highway in peril. And in addition, since it's slowing down, nothing new happening, the observatory is okay. So that was a big concern, but thank goodness that this is over with. The road did get cut by the lava flow, as happened once in the 1980s as well. It takes a couple of months for the lava to cool off enough so that they can then drill holes in it, pour in hundreds of gallons of water to cool off the lava, and then place new power poles to run power back up to the observatory. So probably a couple of months before they'll be back online.
So,
Okay.
David, are they without power now?
Yes, they're without power now.
It's not just the NOAA observatory. There's other observatories up there, like the Gong, NSO's Gong sites up there, and it's down now too. So
That's right. Yep.
is
They have,
Gemini? Is the Gemini
no.
telescope up there?
No, the big
That's
big nighttime telescopes are all over on Mauna Kea. Gemini, Keck, Subaru. These are smaller and actually a couple of solar sites. They're on Mauna Loa. When I worked up there, we parked the car faced downhill, just in case if you got some warning that you needed to abandon the site suddenly, the car was pointed the right way.
I've
Okay.
been up there at that observatory once, and I always kind of wondered if they were situated where these kinds of possibilities would happen. Apparently, yes.
Apparently, yes. The last lava flow at that particular site was in 1935. And since then, the Northeast Rift Zone has been erupting to the east of the observatory. That 1935 eruption, the lava actually came out of the caldera off this low corner right here and came straight down that direction. That was before the observatory was there. But it's kind of in the 100-year in peril zone. Which is great because you don't have anything growing. So measurements that are made up there are not polluted by anything around it. I don't think there's a plant growing for 5 kilometers anyway of the observatory site.
It's like the moon.
Mm-hmm. And it's pretty sensitive measurements. They detected a freon leak in the observatory car and said, go get it fixed.
That's fine.
Okay.
Cool. All right.
Stop share.
Cool. Thanks for doing that. I had not even, hadn't even thought about including it, even though it's important news in astronomy. Community share. Portion. All right. So I have about 35 minutes worth of slides so we'll go through this. I'm trying to remember who, we talked to James Webb, and this is, Leonard likes to call it the James Webb, or Just Wait Space Telescope, but man, just wait until you see some of the new images that we've got. But first, I wanted to talk about a couple times ago, we talked about the spectrum that James Webb looks at, and how the color palette that they're using with James Webb is how it's different, how it's the same as the Hubble color palette. So real quick, the James Webb is infrared mostly. And if you look right here on this diagram of the whole spectrum, we start out with gamma rays and the higher frequencies, and then this is the visible light right here, and then this whole section beyond what we can see with our human eyes. This is what James Webb's looking at, and how this is important is that we can see.
I'm not seeing that. Oh, there it is. There's that screen. I'm sorry.
No,
Okay.
that's okay. Thanks. If there's any technical issues, let me know and we'll figure it out somehow. So James Webb, it looks at the looking at this infrared. If we can see like warm areas of the cool clouds where stars form. One of the interesting aspects of the way the universe is expanding is that it's redshifting. That's means it's pulling the light waves out into lower frequencies, and James Webb is able to see, and we'll see some of those images in here. But this is why James Webb is kind of seeing things a little different, well, a lot different than the Hubble, and certainly a lot different than our eyeballs. So I just wanted to real quick go over some of the instruments on board. There's 4 instruments. There's the FGS, which is the fine guidance sensor, near infrared imager, slitless spectrograph, or NIRISS. And this is really to help guide the camera, point the telescope in the right direction. So that's just one of the instruments. And it has up to 5 microns in the near infrared. So it's closer to the part of the spectrum that Hubble's looking at, and we still cannot see this part of the infrared spectrum, but some of the Hubble instruments could. So that's kind of important to think about. The one that's doing a lot of the work right now also is in that frequency range. It's called the near infrared spectrograph, the near spec, and it's dedicated spectrograph. So it can capture spectra simultaneously across 100 spots in the image. And this is really important for the exoplanet research they're doing. So they not only get spectrograph of stars to figure out what elements are present, but also what elements are present in some of the exoplanet measurements that they're doing, and that they will do in the future. And this is one of the most exciting parts of what the JWST will do. Another one that's doing a lot of the work right now, still in the same near infrared area, is an IR cam, the near infrared camera. This one has a coronagraph, and so it's studying exoplanets whose light would be, exoplanets' light, the spectrum come from it, is pretty overwhelmed by the star itself. And so an IR cam helps tease out that spectrum so that we can study it a little more closely. And then there's the MIRI, the mid-infrared instrument, and this combines a camera with a spectrograph. And it's in the mid-infrared, so now we've moved down the spectrum just a bit more. And this is from 5 to 28 microns. So we can see even more cooler objects, such as debris disks around stars or the extremely dim light from faraway galaxies. And really the question becomes, how do we process these images? We're looking at the way Hubble does it is, I'm going to skip forward. The Hubble palette is made from, it takes an RGB kind of color space, just like your monitor, but it assigns H alpha to the red, sulfur 2 to green, and oxygen 3. So it's looking at these specific wavelengths of light through filters that are showing the H alpha, the sulfur 2, and oxygen, and it's assigning red to H alpha, green to sulfur, and blue to oxygen. And that's how Hubble does it. And that's how it comes up with this unique color palette. I would say that these are all false color images, but they're so beautiful that we sort of think that they're real. And so now the question is, well, gosh, are the James Webb images real? And in a way, the answer is no, because we can't see that wavelength of light. There are 27 filters on the James Webb. They first isolate the most useful dynamic range. And if you've ever adjusted photographs in like Photoshop or something, that's where you stretch the light out, or you find the dynamic range that's working the best. And then the second thing is to assign, and they assign each infrared filter to a color in the visible spectrum. So the shorter wavelengths get the blue colors, and the longer wavelengths get the red colors, or green, and red. And so it's the 27 filters are assigned per where they are in the spectrum, and that's the color that they're going to use to process and color the images. So I think there were some questions how we do this, and that right there is the answer. Instead of taking RGB values, we're taking 27 colors and put them in the image to give us something that makes sense to our eyes. And then, of course, they do some balancing and adjusting after that to create just the pretty pictures. So I really quickly wanted to go through that because I'm going to spend a bit of time talking about James Webb, because their drumbeat for new images and new data has been about every 2 weeks, and it's been fascinating to watch. Especially, this is kind of cool, in this age of selfies. They took one of their instruments in that NIR cam, and it's basically a selfie of the primary mirror through this instrument. I'm like, that's pretty cool. But some of the things that they're finding, like I told you, that this is one of the oldest structures, this group of galaxies. It's about 11 billion light years away. So they'll see older structures. They're hoping, and we think they will. But like I said before, this light at the edge of the universe right now is being redshifted at a high rate. So it's moving farther down in the infrared sector, perfect place for James Webb to be looking. Hubble could see it a little bit, but not to the extent that James Webb will. So pretty exciting times. This is called the, man, I had a note on this and I forget what it's called. It looks like a bow tie or the butterfly, but again, this is taking those 27 filters and assigning them all, since the light of this is pretty orangey red. On the left, it's going to be cooler gas, and then the hotter gas, which probably is not much hotter, is on the right. One of the cool images that came out, because of the use between the near-infrared camera and mid-infrared cameras, was this image of the Southern Ring Nebula. It came out a couple weeks ago, and it just fascinated me to see this kind of ghostly glow in the mid-infrared. So they're showing more detail, excuse me, than what they normally would by combining these two images. So the one on the left, again, is the near-infrared. That's closer to the visible spectrum. And then this mid-infrared is a bit shifted down. Because the James Webb has been so sensitive, so high resolution, they're looking at these very, very small spots in the sky. And this is called an Einstein ring. And what we're really looking at is that bright blue spot is a quasar. And the ring around it is a light ring caused by probably the bright spots in that ring are galaxies that are directly behind the quasar. But because the gravity is so intense in the quasar that it's warping the light. And so we can actually use that to see beyond. So things that are even deeper in the universe. Einstein predicted these as part of his special theory of relativity. And so it's kind of neat. Every time we figure out that Einstein was really right, it's always a good thing. Now Hubble saw these rings as well. So this is not new science, but it's always cool to see it. Another cool image that came out, we see this, the pillars of creation kind of turned on the side. This is in part of the Eagle Nebula. And this is the mid-infrared image that they showed. And then I couldn't get it flopped over, but because of the orientation of this slide, but this is in the mid-infrared and near-infrared composite. And, we can see the differences here are kind of subtle, but this one's a lot more ghostly. And when you look at it high, if you zoom into it, there's a lot more structure in this, the mid-infrared areas. And so the scientists have been pretty excited about these new areas that they can explore. These structures are somewhat visible in the Hubble image, but they're a lot more detailed and a lot different. I showed this image the last time we talked about images because I always like to show the pretty pictures. Another image that just came out was colliding galaxies, IC 1623, just showing those red areas are in the Hubble images. Those are areas of what are called starbursts. There's where star forming areas when galaxies collide, the gas gets disturbed, compressed, and so it creates star forming regions. And that's what those are. Those blue areas are also hotter, younger stars, but not part of this collision. Well, the whole thing is interacting. So in billion or so years, those two galaxies will come together and into one big galaxy. So this is another image that is of a dwarf galaxy. And the dwarf galaxy is some of the stars you see at the left edge. And then the brighter stars, like the one at the very top and the one over in the lower right corner, are in the Milky Way galaxy. There's one right in the middle. And those brighter stars are in the Milky Way, but everything else is farther out in the universe. So we're looking at these faraway galaxies through a dwarf galaxy with foreground stars in front. So just so you can get a little oriented with that. One of the more interesting things they did was on November 4th, the JWST camera looked at Titan. So this is a moon of Saturn that has an atmosphere, and it's nitrogen rich, and it covers the moon like a shroud. So it's 50% denser than Earth's, and it blocks all visible light. So we can't see this directly, but with a few tricks that they've devised with images from Cassini and things like that, they can use infrared techniques to kind of see through that. Well, since James Webb is an infrared telescope, this is a perfect reason to look at Titan. And the scientists are really excited to see this. Now, this came out just last month. The scientist who got the time on James Webb to do this was super excited to see clouds. It's cloud B over on the right and the cloud A. It made him so excited that they tasked the Keck Observatory to look at Titan. It's another infrared telescope on November 7th. And so we can see some cloud movement. You can see the section called Ballet, the dark feature on Titan has moved. Ballet is probably a sea of methane. So, and it just registers dark. And I love the marble looking quality of these images. It's just a totally different way of looking at the universe. And, this is a beautiful picture of Jupiter. So we're looking at things closer, and we can barely see the ring around Jupiter. Now, Voyager helped us discover this ring. We couldn't see it from Earth. We can now with Hubble and stuff, but before it was kind of evaded detection until we went out there with Voyager. But with James Webb, maybe we'll be looking at that a little bit more. And we'll also be looking at the Great Red Spot. This is another image. And this image highlights the aurora that we can see. Now, this is a picture of, it's a segue. We're done with James Webb, and now we're moving on to Juno. I started with this Jupiter has a magnetic field that's 20 times stronger than Earth's. And so it has some of the most awesome aurora in the solar system. And we do too on Earth, but one day I'll get to see this. But Juno captured this image with aurora in the southern hemisphere. And there's also aurora. You can barely see it at the very tip of the top. You can see some aurora up there as well. Just like Earth, the magnetic field goes to the poles, and those solar particles work with the to cause the gases in the atmosphere to glow in that blue. This image is one of the cyclonic storms in the polar area of Jupiter, and it just is so artistic looking. What the Jupiter is throwing out at us, and Juno is able to pick up. And then this image here of the cyclonic storm. And one thing to point out too is the Juno's been this is the 46th they call them parajoves. It's the closest approach of Juno to Jupiter. So it's the 46th. And I can't remember when Juno went to orbit, but it's going to be just like Galileo. It seems it's going to go and go and go. So these two images, the one before and this one of another storm on Jupiter, these were, I don't know how many people follow, but the missions that NASA does, and they put all the data up into what's called the planetary data system, and you can go and download the data and process these images. And these are all done by, this one was done by Brian Swift. This one was done by Navani Krishna. And these are citizen scientists. They get to, they download the data, they do their magic to these images, and then they can share them back with NASA and they get credit for it. And so if you're interested in ever doing this, just take a look at that. PDS gets updated, I don't know, I get emails about once a week with new info. And they come not only from Juno, but also any other missions that are going on. So, you can go back and look at Voyager data and stuff like that. One of the exciting things that in this last flyby, that when Juno went closest to Jupiter, was that it flew very close, within 219 miles of Europa. Now, Europa, it's still 3 times, it's not 3 times, it's the 3rd closest approach by any human probe. Voyager beat it. We got those spectacular pictures of Europa back in the 80s, and then Galileo in the 90s was closer still. And Europa is one of those moons, one of the 4 Galilean moons, the largest moons. And it's going to be one of those places that we are wanting to look for life, because it probably, from all indications, has a liquid ocean underneath this crust of ice. And so these cracks are, from Jupiter and the other moons pulling on it, creating these cracks and stuff like that. So more exciting images will come in the next few years. And this is another, Andrea Locke got this, she's another citizen scientist who processed this image, closer look at these cracks from the freeze thawing type of thing that goes on Earth. So this is a different picture of one of the coolest stories that's come in the last, 50 years. This is Oumuamua. This is the interstellar object that came blasting through the solar system in 2017. It was discovered by Pan-STARRS in Hawaii. And it's way outside the range of telescopes now. We can't even see it. But in 2019, Sergei Mashenko, he did an analysis of the light curve, and the only way that he thought that the curve of the light fit the shape was if it was pancake shape more than the cigar shape that we normally see. And I didn't include that one, not just because I didn't want to confuse it, but so it's 6 times wider than it is thick. And so it measures about 113 by 111 by 19 meters. So it's not very thick. Another scientist, Steve Desch at Arizona State, in November, presented a paper and explained that the shape probably is related to the asteroid being affected by the sun itself. The only way that he described it was that it may be made of just pure nitrogen. So this object, if it came from it obviously came from a different solar system, it formed similar to the objects we have out in the Oort cloud and the Kuiper belt, comet-like objects. This nitrogen being very cold. And so one of the side effects with a close encounter with the sun, even though it didn't come into the inner solar system, it's still, there was still a lot of solar pressure and warming on this object, and nitrogen being very volatile because it's, it got warmed up pretty bit. It probably burned off about 90% of its mass just encountering our sun. And so it barely survived. And so it's now leaving the solar system a lot thinner than it used to be. If, I would love to go on a diet like that. It's just me.
I think it's actually the Millennium Falcon.
Like it. I wonder if Han Solo inspired me. One of them, we talked about this earlier in the year, one of the more exciting, this was right at the beginning of the year, they announced the Event Horizon Telescope. It was a series of 8 or 11 telescopes spread throughout the world. They were looking at the black hole at the center of the Milky Way galaxy. And this is the image they came up with. If you've seen the movie Interstellar and the black hole representation there, this matches that theory. Kip Thorne was the technical scientist or whatever, person on that team, and that's the way he thinks this whole what a black hole might look like. Looking at it, anyway, this was pretty exciting that we could see this black hole, and I don't know if they're going to use the techniques to look at other black holes, but I imagine that given the success and the press that this got, they probably will do that. I don't know if you all know this image from Voyager. This is Mimas, another moon of Titan. Of Saturn, along with Titan. And what's interesting to me about this image is that we call it the Death Star moon because we saw this image originally in about 1981. And, Star Wars had already been out for 4 years or 5 years before we saw this impact crater on this tiny little moon. And we think of these bodies out there as solid ice, just frozen solid, but there's some scientists in the Planetary Science Journal Icarus, they're proposing a study now that there's signs that there may be an ocean under that icy shell. So it's not maybe as solid ice as we think it is. And, of course, water is an important ingredient for habitability of Earth. And we may think that possibly there will be, that could extend out to other parts of the solar system or parts of the universe. I don't know if any of you have read Hail Mary, but this all gets thrown on its side. This is from the author who wrote The Martian, Andy Weir. So if you haven't read it, it's an amazing read. You should check it out for Christmas. I highly recommend it. Hail Mary was the name. Where are we with exoplanets? We're finding them left and right, and we're over 5,000 now that we've found. And I've put this graphic in from Scientific American. That's most of what we've found is like Neptune-like, right? So only 4% are terrestrial, 31 super Earths, and 30 are exoplanets. Gas giants. And so what's been neat about watching this area of research this year is that we are finding out that our solar system is nothing like a lot of the solar systems that we're seeing with the Kepler instrument, and now the James Webb is going to be looking at these, and it just is throwing our ideas, our preconceptions out the window. The idea that in our solar system, all the rocky bodies are close to the sun, and then there's these gas giants, and then the more volatile stuff is frozen out in the frozen giants, Uranus and Neptune, and then there's the Kuiper Belt, Kuiper Belt, and then the Oort cloud. So that's what we thought all solar systems formed like, but no, that is not the case. And it's showing us things that we couldn't even imagine in science fiction, such as one of the exoplanets found this year was WASP 121b. And it appears that there are airborne metals and gems existing in the dark side of this planet. And metallic clouds are something that we have no experience with. There's nothing like this at all in our solar system. But 855 light years from Earth is this planet with gems falling out of the sky. So, I mean, I'm sure that science fiction writers are going to take this and run, and I hope that they do. We have this, we think that all planets are maybe round, especially the big ones. But in this case, this WASP 103b, this would be the second planet of this star. A being the first, and I don't know where that one is. They designated this one B. But this thing is 2 times bigger than Jupiter. But it orbits in just a single day. And the reason it's rugby shaped is because it's getting pulled. It's going around the sun so quickly that it's just stretching out like a rubber ball. And again, blowing our minds with what can happen. Another one is, this one's TOI 647b. This is an artist. These are all artist renditions of it. So these aren't real images. They're just what we think they look like from our artists, given what we know. This one's 150 light years from Earth, and we've detected water vapor in the atmosphere. And this is a little different for a Neptune-sized object. Before, we've seen the same chemical makeup. That's why they're called super Neptunes, is because they, had these planets had the same, exoplanets had the same characteristics as our Neptune, but this one has water vapor. So this was another one we found this year. And this one's wild. This is AB or Righe B. And it's a giant exoplanet that's still forming. So they've detected this thing in a protoplanetary disk that they estimate is just about 2 million years old. So it's brand new as far as, astronomical terms go. What's wild about this is that this is a really humongous planet. It's 9 times larger than Jupiter, but it orbits at 8.6 billion miles, which, if you know how far Pluto is, which is like 4.1 billion miles, this thing orbits twice as far out. And so again, we're being, this is way outside in the Kuiper Belt somewhere in our solar system. So how these things form, these are the answers or these are questions that scientists are asking this year. And this last one from exoplanets is this planet TOI 1452b is close to the same size as Earth, and it's in the part of its solar system that's what we call the Goldilocks area, where liquid water can be present. But it has such a low density that scientists speculate that, unlike Earth, which is made up of mostly rock and metals, this one might be an ocean planet. Maybe it might have 10 times the amount of water that Earth does. So it may have a little rocky core, but it's mostly water, a very, very deep ocean. I can't wait for Michael Carroll to give us a picture or an image of that. Michael Carroll is our friend who lives in Denver, who is a space artist. We've had a couple times. Moving on to some, I tried to include some stuff that I thought was kind of interesting in this. And this is I think this is an artist rendition. Oops, where am I going? This is an artist rendition of one of the papers that came out just this past month again was the United Arab Emirates Space Agency launched a probe towards Mars last year. And it was known as HOPE. And it's taken snapshots and it's found these ribbons of green going in the atmosphere. And they think that they are aurora that they're seeing. And what's interesting about this is that these are more in the ultraviolet realm of things instead of the visible light, northern lights that we have. But I think what's more interesting about this is that this is totally unexpected because Mars' magnetic field is very weak. And so we didn't expect to see aurora. And yet here it is on Mars. So that's kind of cool. I know you've all seen this image. This is from the Viking 1 site. And scientists have always been a little puzzled by the big boulders that are in this field. And there was a paper in December 1st from the Nature Scientific Reports, Alexis Rodriguez. She's traced the source of these boulders to a site that's about 100 or 900 kilometers away, to a 110 mile or 110 kilometer, doing very good with my units today, 110 kilometer crater named Pole, after the Frederick Pole, the science fiction author. This impact happened during what's called the Great Bombardment, 3.45 billion years ago. The moon shows, evidence of this where just everything got pounded. Earth has a few, but because we have weather and plate tectonics, this kind of get worn down. But this asteroid or something hit this area of Mars, and it was big enough to whatever ocean was there at the time. It caused a mega tsunami that threw this debris out. And we're taking this kind of idea from Earth. On Earth, geologists knew that there were some deposits about 65 million years old, right at the same KT boundary of the whatever impact that happened that killed off the dinosaurs 65 million years ago. They were finding these deposits of gravel and rocks in like the Caribbean and Texas that could have they were deposited by tsunamis. Now on Earth, we know what a tsunami deposit looks like from a historical standpoint. So the geologists are pretty sure that this is what was going on. And so they used the same sort of thought process and the mechanics to figure out this Martian tsunami. And also, it took years and years and years to find the Chicxulub crater in the Yucatan Peninsula finally to sort of nail the head on the coffin. Big news we've learned from Dan Durda this year is that we can nudge an asteroid. This is a picture from Hubble of when DART smashed into Dimorphos. And we actually were able to nudge, it slammed into this space rock going about 14,000 miles an hour. It was destroyed instantly, and that's what caused the bright light. But it moved Dimorphos off its course just a little bit. So these science fiction movies where we send up an astronaut to get out and push the asteroid away, it might really work. I'm being futzy. Anyway, Hubble still is doing science, and it's observed what looks like the largest snowball ever. This is a comet with a nucleus that's 85 miles around. It's called Comet Bernardinelli-Bernstein, and it's about the size of Rhode Island, or twice the size of Rhode Island. And it's just so much bigger than what we've seen before, especially coming from the orbit that it's got. It was coming from way out in the Oort cloud. Now, these kind of comets usually get bad rap because they are almost always, if you've seen the movie Look Up or some other disaster movies, there are always comets from way out in the Oort cloud. They get nudged and they come and smack Earth. Well, this one we're safe. The closest it'll get to Earth is the orbit of Saturn. And so we're cool. But Hubble found it. Disaster again. Another gamma ray bursts are one of those weird puzzles in the universe. They come from only a couple sources. One is a supernova explosion, and the other is from what they think are the merging of whirling super close neutron stars. So we get these gravity waves that come out, but they also come up with these high energy bursts. And usually in the past, they had detected, they said, well, if it lasts like a minute, then, then it's probably from a supernova. But if it's a long, shorter burst, really short second or something like that, that's from the neutron stars going really, really, really close together and finally collapsing. This gamma ray burst that the Fermi Gamma Ray Space Telescope caught in December last year, so I'm kind of including news from last December, is that it matches neither of those two instances. And then so scientists are scratching their head. They go, we got this. In this instance, there was a long burst and then a short echo. And so they wonder if it really wasn't two neutron stars colliding and just happened to be a little different. But, this object is really, really far away. It's so hard to figure out what to do with it. Oh, that was a lot of space news or astronomy news for the year. Some things coming up for 2023 to watch out. If you're like John Astelos, and you like to go out and observe things that only come around every once in a while, like comets, then this is C2020 V2. This is where it's going to be over the next few weeks. This is Ursa Major, the Big Dipper. Polaris is up above, well, it's over to the left. So this is, anyway, so it's going to go right over the top of the sky. Unfortunately, you won't be able to see this with your naked eye. It's the brightest it'll get is about 9, magnitude 9 in late January. So it's very, very dim, but it's something to check out. I mean, comets come around. We were talking about comets, so I thought I would throw it in. And we also have one that we may actually be able to see coming up in by the third week of January. This is comet ZTF E3, and it's again north, going up in the northern part of the sky in late in the evening. And on the night of February 10th and 11th, it'll be close to Mars. I mean, they'll be within 1.5 degrees. So they'll be closer. They'll be about, well, they won't be as close as the Mars was to the moon the other night from my vantage point, but they'll still be close together. So if you have a telescope, you'll be able to, there's not much of a tail on this, but you should be able to see a kind of a coma, a fuzzy bit of light. So if you like to go out and have a telescope and want to check it out, then you can do that. We have a big total solar eclipse next in 2024. And 0223, man alive, I mistyped that horribly. But this year on October 14th, in about a year, in 2023, John can't type. We have what's called an annular solar eclipse that is within striking distance of Denver. And an annular solar eclipse is where the moon is slightly closer to the Earth than normal, and so you get the ring of fire. You get the ring eclipse, and that's always pretty cool. And so Barb is super interested in some of the photos that I've been taking here in Massachusetts, and because it's kind of wet up there, I got sort of into taking mushroom shots, which aren't astro photos, but I thought they were pretty cool. But this was the full moon rise in October. We were in Dartmouth, Massachusetts. This picture was taken east of New Bedford on a beach, and that's another part of the part of Cape Cod that kind of dips down This is kind of the southern edge of Cape Cod that we're looking at, that's rising over. And then this was in the email. I was playing with the water that was splashing up. I'm trying not to get my camera wet, which I was successful. And then this was going on just opposite of those images. The sun was setting behind this grass, and it looked like it was on fire. It was so incredible. Right now we're in Gulf Breeze, Pensacola, part of Florida. We left. We've been here a week now, so we've spent 3 months in Massachusetts. We'll spend 3 months here in Florida in our little adventure. And we went out to the beach the other day, and we were supposed to get the moonrise over the ocean, but the sunset over the ocean. I have Photo Pills as an app that tells me where the moon rises and where the sun sets and all that. And boy, it was off. It showed something different. I don't know why. Maybe I was just in the wrong place, but spectacular sunset. And John, I think I got the green flash. What do you think?
A little bit.
This is the best I can do, man.
Yeah, keep trying. You got a good place for it. Looks
Yeah.
like on the left edge, it's a little greenish.
Yeah. So anyway, I was like, well, I'll let John decide. I'll keep trying for you.
It's not easy. You gotta, keep trying.
One of the things that I was doing up in Massachusetts was playing around with untracked astrophotography. So I took about 4 minutes worth of the Pleiades. So it was just 1 second exposures with a really high ISO, hoping to get some nebulosity, but I think there's too much light pollution for that. I'm still working on this image. And then we had close encounter the other night. This is my image. Here in Florida, the Mars scooted right along the bottom right edge of the moon. It was 3 arc minutes away, the separation between the moon and Mars. And then I was going to take a time lapse of this passing, but right after this image, it got super cloudy, super foggy. And so the images weren't very good. And so I kind of gave up on that. Mark, though, got this image of Mars. Well, Mark, do you want to talk about this image?
Yeah, so I used my Nikon P1000, and I was standing outside of the lab building where I work at NREL. And I didn't know really what time I was going to make first contact. So I just stood there for a long time, taking a bunch of pictures until I could get this image. And then on the next, so at any rate, I kind of lucked out. That's the exit image. So I had to do the same thing. I had to go back outside and kind of really watch carefully. And so this was the tougher one to really not miss it. And so I was able to get it just as it was coming out.
And what was go ahead, sorry.
No, that's it. Go ahead.
Well, I was wondering what you said what camera did you use? What lens? What was the
It was a Nikon P1000. So it's a point and shoot that has a really long zoom capability. It's just a 16 megapixel sensor, but it's got some optics in it that allows really long zoom imaging.
Bless you. Pretty cool.
Yeah.
That's all I've got. John, you want to share? And then Dave?
I needed to unmute. There we go. Okay. Select the window. Yeah, here's my close-up of the same event. Can everyone see that?
Mm-hmm.
Yeah, so this is a few minutes after Mars came out. You can just barely see a little bit of detail. Samarium region. And I have a little tale to tell. Yeah, Mark had actually called me up before the occultation started, and I know what kind of camera he has. He doesn't even have to put it on a tripod because it's got such good image stabilization. And he says, "Well, I'm going to go out and take a few pictures." And I'm thinking, I need to get going here. I have to set up my equatorial mount and get the drive working, get the telescope on it. And so I was a little bit envious of because I've seen his shots before of what you can do with a handheld camera with what is it, about a 30x zoom or something. Anyway, yeah, this is my close, well, it's a crop of the full frame. Now what the heck? I need to switch because, well, here we go. I think I'm trying to advance the pictures ahead, but I can show you this. Do it this way. So here's the full frame with Mars right there. I didn't enhance Mars at all, so it looks a little faint. You know, with Photoshop, you can just brighten the one part of the frame up a little bit if you need to. So yeah, that's that. Now,
What was cool about this occultation was that, you know, this is a full moon. Mars was at opposition, so it's the brightest that's going to be this year. I mean, this was just like a perfect planetary alignment for real.
yeah,
For this.
I think the moon was like an hour away from full, and Mars was a day away from opposition or something like that. Really, what a coincidence. So yeah, I have one more picture. Now, whoopsies.
We're still seeing that very first image, actually, John.
Oh, are you seeing anything else now?
Mm-mm. No, we haven't
Really?
seen the other. No. Sorry.
Well, okay. I don't know what's going on here.
Another perfect, flawless meeting.
Do you need to unshare and then reshare a different window?
Yeah, maybe I should do that. It's 1 second. Okay, I'm gonna reshare now. Downloads, okay. So I guess that, okay, here's this now. Are you seeing a picture?
No, we see your file, downloads folder.
Well, I'm trying to show you a picture in the downloads folder.
I understand that, but we're not speaking on a different screen.
I'm guessing you have selected one window to be displayed. And then whenever you call up a picture, it's not showing that window, it's showing the first window.
But you can show it the way you're. Oh, it was there for a second.
Okay. Well, let's try that again. Yeah, it's asking me what window I want to share, and let's try sharing the screen.
There we go.
All right. Yeah, it gave me too many options. So this is the full frame, right? Okay, because that's what I see now.
Mhm.
And now, see if I can show you the other picture. Now this is taken on actually the morning after our last meeting. Wasn't our meeting on the 19th?
something like that.
Yeah,
of November.
right.
Saturday night. Yes, this is Sunday morning. And I went out with the same equipment as we were talking about. And I thought because in Sky and Telescope, the libration would be favorable to see Mare Orientale, which is right here, that it would be good to go out and get a picture. However, the libration was not that favorable. It just shows as a flat spot, sort of right there. But I took 10 different exposures and stacked them and got this.
Pretty nice and beautiful.
Yeah, thanks.
Yeah, that's really beautiful, John. Great.
I was out there with the owls and everything,
Ooh.
5 o'clock in the morning. Okay, well, that's all I have this time. So I will, if I can get here we go. If I can, trying to unshare screen now. Oh, there it is. It's up there. All right.
I was
Sorry
gonna say,
about
I can force it if you need to.
that.
All right, David, you got something cool to show us? Dave Elmore.
He's trying.
Oh, okay. I saw you on mood.
Are we here?
Yeah, I see something cool.
So you folks see the spaghetti nebula?
Yeah, that's cool.
Yes.
So these pictures we have been seeing are kind of, well, James Webb, remember the original press conference, they indicated the field of view was about as big as a grain of rice at arm's length. This one is about as wide as your hand at arm's length. It's 9 moon diameters across and sort of 12, 14 tall. Supernova remnant that I took with my 1/10 of a meter aperture telescope in New Mexico remotely. And it was kind of fun several months ago when several of you looked over my shoulder while I was taking images with that telescope. This is 7 hours of exposures in narrowband using the Hubble filters. But what I'm trying to do here is to express those filters more in a realistic way. So red hydrogen alpha light is shown as red, and teal colored oxygen 3 light is shown as teal. Then I was left over with what do I do with sodium emission, which you'd think would be yellow, but actually sodium 2 is redder than hydrogen alpha. So I decided, well, let's just make sodium 2 yellow. And the combination, you can see regions then in this supernova remnant where the conditions are just right for hydrogen alpha to be excited or just right for oxygen 3 to be excited. And then a lot of places where there's kind of yellowish orange where sulfur and hydrogen alpha kind of overlap each other. So this star blew up about 35,000 years ago, about 3,000 light years away in the Milky Way. It's pretty faint. It took several tries to even find it in the sky several years ago when I first tried to look for it. But it was 7 hours of exposures, narrow band with a dark sky. I thought it came out pretty well.
I think so.
Yeah, that's gorgeous. Wow.
I did
Nice.
another field. This one is 10 moon diameters tall, so 10 by 20 or so. And this is a star forming region that is kind of gone through most of its star forming life, though there are some interesting Hubble-like features still here, some towers of creation. But this whole region is being excited by light from stars over here. That this star is 50 times bigger than the sun and emits thousands of times more light. Is 50,000 degrees surface temperature, so it's very high energy photons, and those go out and blast atoms in this molecular cloud, and then as they recapture electrons, they emit in this same Hubble palette. The teal for no, this is a different Hubble palette. This is more like what they typically do, where sulfur was red, hydrogen was green, and oxygen was blue. But for this particular target, it seemed that that particular choice of a color palette brought out where you were seeing emission from the particular atomic species better. So those are two examples of things I've been doing from New Mexico in the last month or so.
Wow, cool.
Yeah, that's, yeah.
Now we see lots and lots of little
Very nice.
stars that are closer to us than the gas behind it.
Well, they could all be they're all in the Milky Way. So I can't say whether those stars are closer or more distant. I do know that right in here, the star is the same distance as the nebula because it's the one that formed from it and that it's causing it to emit right now. But I can't say about any of the others. The star cluster is probably very much more distant.
Where is this located?
Oh, that's a tough question.
Sorry.
It's pretty far south. It was, it's off to the left of the Milky Way. So what's that constellation over there? Serpens? Could that be it? I don't know.
So David, you've got one refractor and something piggybacked on it. I don't remember.
I keep changing my mind. This is with my 107 millimeter aperture f3.9 refractor, hextuplet apochromat. And that's my long focal length telescope at 420 millimeters. And then my short one is 100 millimeter aperture f3.0 octuplet apochromat. And this is the one I have the Hubble palette filters on. The other one I have an RGB camera with a dual band filter, as well as just red, green, blue.
Yeah.
So I'm about to put my Sigma Art lens back up down there, though.
Oh, okay. Great. And your roof's big enough or wide enough?
Well, the roof rolls off, right?
Yeah, yeah. I mean, field of
Didn't you say
view
it
is
was pretty-
an
Sorry.
issue.
Yeah, when you can roll the entire roof off, that's not that big a deal.
Yeah, great.
What's
I
the
can-
focal length of the Sigma?
I've got two. I've got a 50 and I've got a 20, but it would be the 50.
Oh. Okay.
That's what Mark turned me on to a few years ago.
They
And
are good.
I've photographed the entire sky with that 50 millimeter lens.
Yeah.
Yeah, I'm glad I told you about that.
Me too.
They are expensive. Aren't they expensive though also?
Less than a flight to Chile to use it.
Does anybody have any more questions for any of the photographers or myself? We need to let Leonard get going, so. Questions? You may be muted. I probably muted everybody. See if we can unmute and ask.
Yeah.
All
Anyone,
right,
good questions?
going once, twice. Leonard, it's all yours.
Okay, share screen. Let's see what happens.
See what happens. Let's have my
Okay.
chaos now.
Yeah, oh, I think, let's see if this works. Let's see, and then. Can you see the, says SkyWatchers December 10th, 2022? Can you see that?
Nope.
No.
Okay,
Oh, wait.
There we go.
Yes, we do.
yeah, it just, yeah, it took a minute to go. Okay,
Patience is a virtue, right?
Yeah, that's what they say.
okay, so ready?
Yeah, well,
Let's see.
I don't have any sky shows.
Mhm.
I'm using everybody else's photos.
But let's see if it advances.
No, here we go.
Oh, God. Okay. And John, you have it in case we can't get this to, oh, no, maybe it's just slow. It's, okay. There you
Yeah,
go.
but I do have it if you need.
Okay.
Okay,
I think it'll work, you know. 'cause
Okay.
which one did you use?
Just,
Oh.
yeah,
Okay,
this way.
okay.
Okay, wait, but explain what that is.
Yeah, this is a piece of artwork.
Oh,
No, we're going to the moon. Pretty cool. There's a lot happened here in the last week or so, and I thought I'd just give you a little update on Orion and the Artemis 1 mission that's underway. Oh, I see. Okay. The thing about what's coming up tomorrow morning, you know, they're going to land the Orion capsule from the Artemis 1 mission. It's nobody on it. It's uncrewed. And it's landing on the day that 50 years ago, we landed Apollo 17 on the moon, Jack Schmitt and Gene Cernan. And that here's Jack Schmitt on the moon, one of my favorite shots.
one of your favorite people.
Yeah, one of my favorite people. But anyway, they, you know, with all the uproar about how much this thing costs, it was quite an uproar when it took off. I mean, it's pretty amazing. I'm still talking to people that saw the thing go. Okay. And so.
And you're seeing this, it's advancing, right?
We're seeing the,
Oh, good.
Yeah.
Okay.
Okay.
So
we're
that's the
seeing,
liftoff.
yeah, we're seeing the liftoff at like,
Okay. And, you know, I mean, everybody was pretty amazed at the power of the, I listened to Andy Chaikin, who's one of my favorite authors, and he said one thing about when you saw the Apollo or the, Apollo 17 night launch 50 years ago, compared to the Space Launch System, he said the thing really left the pad, this new rocket. So that was one of his impressions of it. But anyway, Artemis flew, you know, past the moon. Again, it's unpiloted. The main thing, you know, one is to make sure that the vehicle, the launch booster worked. It did. It put it on a pretty precise trajectory, flung it out past the moon, the capsule, and some of the imagery from the cameras that are mounted on this thing is really spectacular. And so this is a real picture. You almost have to say that anymore. This is a real picture of the Earth and the Moon and the Orion spacecraft zooming by. And here are some flyby of the moon. It did it twice, once going out and then coming back on its trajectory. Here are some pictures that it took from the Orion capsule as it flew by the moon. Pretty spectacular. Anyway, the main thing I'm trying to get to is just that it's coming home tomorrow morning, and
What's the time? 9 a.m.?
I have it here coming up.
Oh,
Yeah, there it
Okay.
is.
So, you know, that's the link, but if you have NASA TV, you can just go to NASA TV and they'll cover it, or this website, which is NASA TV on, you know, if you need to go through your computer.
Yeah. And the main thing we got to watch for here, and this is why the thing was launched to begin with, is to test the heat shield. A good part of the manufacturing process came from Lockheed Martin local. So a lot's riding on this. You know, this is trial by fire, literally on this heat shield. So it's coming back at 25,000 miles an hour. You know, it's sort of got to work. Otherwise, there's nothing to recover. So that's going to be tomorrow, and that's how exciting that is. At 9 o'clock our time,
Don't miss it.
NASA starts doing its thing. But the big, you know, promise here, heat shield works, and the spacecraft seems to have worked great. You know, if everything goes to plan, you know, there's always delays, but of May 2024, we would put 4 astronauts into the Orion and launch it on this sort of the same trajectory, and come back to Earth without landing. This is again May of 2024, so not too far away. We'll see how this evolves. First crew on the moon, you know, if the Artemis 2 mission goes well, you know, they're somewhat bragging about 2025. So that's the U.S. plan, to put a new crew on the moon.
So this Artemis 2 has more loops around the Earth, whereas we hardly had any.
Yeah.
With one. And there's no super loop around the moon itself.
Let's see. I think it comes back in the same kind of trajectory as this one. So it's gonna.
But it doesn't hang out there like one did, apparently.
Oh
It
no,
looks like
no.
it goes out there and comes right back.
Yeah, I mean, so it's really meant to, again, test the whole system. And one of the people not giving too much credit to the European Space Agency, who built the service module on the end of this vehicle, and it's performed really well. They're very happy with what they've been able to deliver. So I think just yesterday, this morning, I saw some of the elements of the launch system coming together, and Orion itself. So things are moving along to process it for the flight in May of 2024. So it's this is a picture that NASA released not too long ago about potential areas where in the South Pole region where the first U.S. crew to go back to the moon since '72 will land. This is the area that is also of great interest by Russia and China, and almost the same areas. And why is because this is an area that has many craters that are not exposed to sunlight, and but yet offer terrain in that area that you could land and perhaps purge these sun-shy craters of whatever material is at the bottom of these craters. And that, by and large, everybody's excited about water, ice delivered by asteroids, comets, and whatever other process we're going to find out about the moon. So these are collection holes of some kind of materials that could well turn out to be the processing material that would sustain a long-term crew on the moon. Again, this is all artwork. We'll see how well this mission plays out. Again, you know, going back to the moon and understanding the what it's going to tell us is pretty much the thrill of science and exploration, but also the technology. The suits that are designed now are going to be different. I just wrote a little story about tools that they are going to be taking with them on this early Artemis missions, and pretty interesting. A lot of the Apollo type tools held up over the 50 years. That, you know, like a rake, tongs, a hammer. But then they get kind of clever. They got all kinds of new tool belts that they're going to be putting on the suit, and a lot of capability with heads-up display, so you don't fall into the sunshot craters and whatever. But it's pretty exciting, some of the tools that are coming together. Again, one of the goals of Artemis is sustained long-term presence on the moon, and that could entail the building of an Artemis base camp, and that's being planned out, you know, as we speak. But the question will be, you know, how well things have proceeded. I think it will also be generated by international competition and cooperation. But, you know, how long we'll have a lunar presence on the moon is debatable, depending on money. And I kind of think it's the same kind of caliber of facilities at Antarctica, you know, where you have crews coming and going. It's not that far away, really, compared to Mars, but the moon could very well have some kind of Antarctic-like base, and we could have crews going on a regular basis there. That's the dream. Anyway, since we last talked, I think I mentioned I'm always big on what China's trying to do, and they're at the end of a year-long effort to launch modules together and link them together to create what they call the Heavenly Palace. And it's happened. I mean, these folks have gone right down the flight line list of things that they needed to launch individually, and then have the crews, the astronauts, glue them together. And so far, so good. They just, not too long ago, a few weeks ago, a week or so ago, I guess, you know, had a transfer of crew. They had the first 6-person crew on their complete space station, and they turned over the keys to the Shenzhou 15 crew, which is up there now, the 3 people. The other 3 came down and in the Gobi Desert and picked up, and everything was going very well for them. I think one of the things about the whole year was curiosity, you know, Mars exploration in general. I mean, we've had some tremendous capability with the Curiosity rover that landed back in 2012, and it's doing great. It's nuclear powered, and it has done incredible imagery coming back from it for all these years. And more recently, we've got the Perseverance rover. This is in a totally different location, and it's, you know, moving forward on the question of life on Mars. You know, was it there? Did it die off? Is it still there? Where is it if it's there? They're moving forward with Perseverance, and it seems to be doing just great. It has a key mission, which is sample collection, and it's done some pretty amazing work now on gathering samples. They're about ready, I think, coming up on deploying some of the samples in an area that will be later visited by the return sample program. And I got a little slide of that. Then it gets really complicated. This is going to be, you know, interesting to see how much this is going to cost and how it's going to all work. But this is the NASA plan, 2030s. We're going to have a return sample program. The samples that were collected by the Perseverance rover will be cached and they could be picked up by the Perseverance rover, or they're talking about using a helicopter now to pick up the cache samples and bring them to this lander that's sitting in the foreground there. The thing to watch on this is really going to be complicated. That lander has this rocket inside of it, and it actually tosses it up in the air. And once the samples are on board in the front end of that thing, and they toss this rocket into the air and it ignites and goes up in rendezvous and transfers the samples to that orbiting vehicle you see on the top, built by the European Space Agency, if I remember right. So it's a cooperative program with Europe. It's going to cost a bunch, but that's where that program is headed right now. But wait a minute. Now, I was going to try to encapsulate what happened, and I gave up with so much, and frankly, we got some good, John did good overviews of, some of the exploration. The DART mission for planetary defense just in September was successful. We've had tremendous, SpaceX has become routine rocketry and first stage boosters coming back on a regular basis for reusability. You got also Elon Musk with all his Twitter feed issues. That's one thing, but he's got a Starship that he's trying to get off the ground in Texas, and that's coming together, and we may see that fly early next year if everything goes right with he and the FAA and all the other people there. But Starship is meant to, that's his dream machine for getting back to the moon and putting a colony on Mars. So Elon is busy working on that. Blue Origin, the Jeff Bezos private enterprise, has had an abort on a unpiloted suborbital tourism module system, and so they've been quiet for a while, but they had successful flights of people this year that were showing the potential for a fairly aggressive space tourism, at least to suborbital heights. And same with Richard Branson and his Spaceship Two activity. He's coming around to start operating that system from New Mexico, the spaceport that's built there. That'll be happening early next year as well. So we'll see how that evolves there. So I guess the thing that's always great about trying to think about the future is like it's impossible. There's some surprises coming. I'm big on contact. I always keep thinking this is the year. We may have picked up some things, but we've also discounted them along the route. And so who knows what's coming? This is just artwork showing signals coming in. That's all that is. That's as close as I can get to some of these other pictures. I'm always fascinated by what we're headed for here. There's some new language in the defense authorization bill that just got through the Senate. I think it's not through the House. I think it's going to the Senate. But there's language in there about trying to understand what people are seeing. And so I'm cautiously optimistic that we're going to have some more hearings, and there's a new report coming out of the intelligence community that's supposed to help shape the debate more than where it is today. But there's a lot of interest in this. I'm certainly fascinated by where this is going, if anywhere. I do have a worry, and that is we've got some environmental issues that I think in space exploration we need to pay more attention to. The mega constellations, the amount of traffic going up into low Earth orbit by country after country is pretty intense. I mean, the launch rates are incredible. And as they go up, we're starting to see more potential for collision in space of objects. That's going to ring bells probably this coming year if we have more collisions of spacecraft. We're also starting to see a lot more debris make it down to the Earth, and not just the ocean, but down on the ground. This is a picture of a piece of one of the SpaceX Dragon spacecraft supply ships broke up and fell. That's in Australia. The guy that found it, he says, I didn't know what it was. I just knew it wasn't there yesterday. So anyway, I think we got some real issues there, and there are some pretty good moves in Congress now in the U.S. to try to come up with new rules and regulations, but I think we're going to see some interesting developments in both the orbital debris collisions and more debris coming down from these tremendous amount of spacecraft going up and rocket bodies. China has got a design on their Long March 5 that the core stage comes in uncontrolled, and it creates a little bit of panic down here on the Earth because they don't know when and where it's coming in. So we've got some issues there. Got never a dull moment in space. This is sort of what my mom always kept singing. So I kind of believe it. It's very hard to predict where we're headed. I think there are some wild cards coming, and I think, we could have tremendous success in the planetary exploration venue, and also we could have great success with human spaceflight. Both China, India is coming along with their human spaceflight program. So, and we've got tremendous capability built into the International Space Station, kind of getting rickety, has some problems here and there, but we seem to be holding it together and putting new solar arrays on it, and it's turned out to be a tremendous asset for testing both human body and technologies in low Earth orbit that will be helpful for lunar and human exploration of Mars. So that's pretty much it. I don't know what everybody else's future is. I just want to make it to the next year and see whatever comes out of all this. Thanks for listening.
Okay,
Very nice.
okay, we stop.
Thank you, Leonard.
Yeah.
Yeah, Dewey.
All I said was, thank you, Leonard.
Oh,
Oh,
thank you.
Good enough for me. I'll see you later.
Yeah.
Yeah, thanks, Leonard.
Does anyone have any comment on these very large satellite? One is called Blue Walker 3. Seems to be
Yeah.
bigger than previous ones.
Yeah, it's a concern, and it's been aggravating the astronomy community already. So it's a forerunner. They have a large solar array on that thing. If I was savvy on this computer, I could bring up a picture of it, but I'm afraid to touch anything. Yeah, so that's adding along with the Starlink, and then we got OneWeb, Starlink. Amazon wants to put up a big mega constellation. It's really going to be unbelievable and we're talking thousands and thousands of these satellites to create these networks, and some of them are already, Starlinks come in pretty regularly now, and they launch 50 more, and so yeah, I think we're in kind of deep yogurt there. Yeah, but So we'll see how it's just another question of what's gonna happen. What kind of regulations are gonna be involved?
I just wonder if it's going to be more prone to collisions and therefore, turning into small little projectiles. How
Right,
far
well,
up is it? Is it a real problem or is it going to fall out of and burn up?
well, okay. Okay, there's a bunch of things there that I've been watching and writing about, and one thing is probably don't ever say burn up. And I had to teach myself that because writers like me, oh, it just burns up. Well, there's new work underway and papers are starting to show the reentry process is cascading all kinds of exotic materials in the upper atmosphere as they come in. So the burnup process is really dissipating chemistry in the upper stratosphere, and it is being linked a little bit to ozone destruction. And as the constellation numbers go up, you're going to have spacecraft regularly re-entering with all these kind of materials in them. So it's multiple pronged problem. And I did see a very interesting idea by somebody, and that is whether we can put up satellites that we actually bring back in this cocoon kind of thing, and let them paraglide in. It's a private company. It's got a kind of a neat idea. I try to follow all those crazy ideas. You don't know which one's going to make it. Yeah, so the bottom line to me is mega constellations are worrisome for the astronomy community. I think of Carolyn Peterson, she wrote something recently. There is some kind of chat about software that you can give astronomers that, can perhaps evade these Starlink tracks or, all the other mega constellations. I'm not sure that's going to be agreeable with everybody, but we'll see. Maybe there are some solutions there. But meanwhile, our sky is changing. Anybody that's seen a Starlink cluster go by, it's either a UFO phenomenon or it's really Starlink.
Well, there have been software imaging processing techniques that they've used for a while to get by the satellites. One of the issues is that, sure, we can do it, but the numbers have gone up so dramatically, like, 25, 30 fold, that it's just a lot more to deal with than it used to be.
And who should pay for that? That's what to me, one of the issues is, who should pay for it? All the telescopes that are, kind of hand-to-mouth operations in some cases. So, I don't know how they're going to get around it.
Well, it's been clear by the attitude of Elon Musk and SpaceX with the Starlink is that we hear you, we don't hear you type of attitude. It's like, yeah, we say we're listening, but then they just go ahead and do it. And the FCC controls all this.
Yeah.
So it's, whether pressure needs to be put on the FCC to say, hey, you need to just not layer everything up in the, make sure it's still good science going on, or they're going to send everything to the far side of the moon or something. I don't know.
Seems they would just launch from French Guiana where the FCC doesn't have control, right?
Well, that is exactly the threat.
Right.
That's
where the IAU is trying to do their best, the International Union. They've probably done, I don't know if probably not fair to say they've done all of it, but they've really mounted a major campaign against these mega constellations. So you see it, but it's going to take international rules and regulations. So, just getting the FCC together on this would be a step right forward. And anyway, I think we got a problem there. And like you said, as the constellations go up, the chances of space debris increasing, and then you have the Kessler syndrome where, you know, more pieces break off into other pieces and they hit something else. And you have what we've seen tonight, rings around our own world, but ours is not ice, it's garbage.
What's interesting about you're talking about the satellites coming down, the SpaceX satellites or the Starlink satellites, because the Earth, right now we're going into solar maximum and the atmosphere heated up, and those satellites and the Starlink satellites were in low orbit and they were just encountering friction and then coming down. They pushed them up into higher orbit now, and actually that helps things a lot, but it pushes it into orbits where, you know, now we're talking getting close to where the space station is at, things like that.
Leonard, what is the probability of these star links that you're talking about can be used for warfare, where one country decides to attack one of the satellites and create the debris and create havoc?
Yeah, this is a question that's evolving, because Starlink and the Ukraine effort, I think it's on again. The Ukraine is using Starlinks, and the Russians are upset about use of the Starlink. So there's some threats coming from them of, you know, would they ever knock down a private satellite because it's involved in military operations. So it's another, we don't want to go there, but I mean, it's just another.
Is that why Elon Musk is so pro-Russia?
I don't know about that. I don't know anything about his politics. I don't know if he is or isn't, but it's you know, it's just it does give you a view of the privatization of space, and then who's buying time on these things? The military. They're trying to back up their own capability in case their assets get taken out. So now you got the and I'm not talking just U.S. This is France and all the other countries do this. So you got this infrastructure that's based on the private sector that are going to be sitting ducks for any kind of anti-satellites in a warfare situation. So anyway, it's just a ratcheting up of the paranoia of living on a planet with, you know, countries that can't work together. So anyway, peacenik time.
By any chance, do you know what the cybersecurity implications are of having the satellites from different countries so close together?
Other than we, you know, there's already been, I would gather from, I guess, did I hear it from somebody or dreaming? I don't know. No, there's already been tests of cyber warfare in space. I think we confused signals. Russia has done stuff to our, you know, to kind of test us. So yeah, and there's been some laser blinding incidents. There's been some, frankly, it's on all sides. And, you know, we don't know what the classified world is doing up there to try to poke holes in the Russian or Chinese capabilities. And they're doing the same thing to us. So it's the tit for tat kind of thing.
Can I make a few comments?
Do it.
Well, first of all, on Ted's comment, the FCC can permit or deny the use of the electromagnetic spectrum. So if they don't like something, they can say you're not allowed to use the wave bands. I don't know what control they have over the launches.
FAA,
The FCC.
yeah, well, the
Okay.
FAA doesn't want.
Yeah. Then
But how then do you control that from another with another country?
yeah,
don't.
you don't.
You don't.
But
Unless it's
then Elon and Space Force just signed a deal to create something called Star Shield now.
Right, right.
And that's, I think what that's going to be is a quick launch response in case the whole GPS system and the Starlink system gets knocked out by a foreign adversary.
Right. Yeah.
So that's coming.
Yeah,
Then let's see, what was my other comment? Well, of course, the US is allowing Ukraine to get access to our satellite data for targeting, Russian forces in the area. So there's all this stuff going on with the orbital assets, and it's just going to get more complicated all the time, in my humble opinion.
Well, it's been going on for a while. When I used to work at Space Imaging, which became eventually Digital Globe and is now Maxar, they're in down there in Westminster. They're the world's largest provider of satellite imagery. Everything you see in Google Maps, and one of their biggest customers is the U.S. government and other governments. But even 20 years ago, when we launched the first high-resolution satellites, there was a lot of talk whenever the Pentagon would come along, and a lot of PowerPoint presentations about, well, what do you do when somebody shines a laser at you from, Russia shines a laser at an imaging satellite and blinds it? What do you do if they try to take over the computer system and point it, or deny you pointing it to a certain place? All these questions have been going on for, probably since the beginning of the space age.
yeah, there's a brand new study out. I haven't even read it, but I just read the title. It was more of the, I think it was by the Government Accounting Office, or what are they, governmental, they changed the name, anyway.
Yeah.
GAO, and they did a good study on the amount of commercial remote sensing satellite data that the US government's buying, intelligence, CIA, because, Big Bird and all those billions of dollars of satellites are targeted, for certain aspects, but a lot of these CubeSats have been put up by private companies, are really cranking out great imagery, different kind of wavelengths, and the government's buying all that data from the private sector. So now you've got a point where if you're going to take out a country's capability, you're going to have to take out the private sector, government controlled military assets, and it's all hands on deck trying to push the siren button.
Well, I thought it was hugely worrying when Russia really threatened SpaceX for the Starlink stuff with Ukraine. And, they said, well, in a war situation, we'll definitely go after you. That was so chilling to hear that for real.
Yeah.
And that was just a couple months ago, right?
Well, there's a cool thing I heard a long time ago at a space weather conference, and it was by an Air Force guy, maybe from Air Force Research Lab, but he basically said that, one of the things they're interested in space weather and understanding it is that can you mimic space weather to interfere with somebody's satellites, and they think, oh, it's just space weather. And check that box. Oh, it's just another incident, and yet you kind of disable them in some capability as a test to see if you can interfere with the downstream or upstream or whatever stream you want. So that was very interesting to me, and I think that's part of the matrix of the whole military space thinking that has to go on as countries aggravate each other to go to the next level.
Well, that's so interesting you say that, because was it in the 1960s, there was a solar flare that knocked out communications with some of the early warning satellites back in the 60s.
Wow.
And it put, the United States went to like their highest level of alert because they thought that the Russians had done something to their satellites. And when it turned out that it was just a space weather event. So, it's like, I think the stories like solar flare almost caused World War III or something like that.
Yeah,
That's so scary that you talk about the flip side of that way. Ugh.
But wouldn't all the different nations know that it was a solar flare versus a man-made weather pattern?
I don't think so. I think you can direct it, and I think, it would be just something that, yeah, it would take, but if you're dealing with seconds of time to make decisions, you're not gonna go and do a computer run and try to figure it out with modelers in the other room. Come back and get a peer-reviewed paper in some journal. It takes a month and a half.
But doesn't the study of the sun would indicate something that's going on, some kind of trend in a pattern of how the sun is responding?
Well, maybe you
Well-
could use that as masking your attack. Oh, yeah, let's
Yeah, well,
just
that's
do it in
true.
solar max. So,
So the-
yeah, I just see it as not good. Sorry, John.
No, you're fine. I was just gonna throw in with Lena, the whole, the sun, it takes 8 minutes for light to arrive from the sun. And if there is a, coronal mass ejection of some sort, it takes a couple of days. And a lot of times these things come, if it's coming straight at the earth, we don't really see it. I mean, we kind of have an indication, and there are some indications that something's going on, but until it happens, we don't know. And so it's so sudden a lot of times that, we haven't, like the place I work right now, the National Solar Observatory, we give, information to the Air Force and the FAA and other places to help with this exact thing. So the Air Force can say, okay, we know Russia's not playing with us but back in the 60s, we didn't have this capability. And so it is better, but I think it's still kind of an iffy thing. And if somebody's messing with your satellites and you have to go, well, are they messing with this or is it a solar flare? That's minutes that, Leonard was talking about. That's like seconds. You have to make a decision to do something that could cost you, I guess.
Okay, I can understand that. At the same time, I would think that if something like that happened, that literally it was happened to the whole earth, not just to one country.
Yeah, well, another way to look at it, if you're on the mean side, is that you can create some kind of spurious signal to knock out the satellite capability. And the first thing that the operator is going to do, well, we shouldn't have bought the magnetometer from, Ed or something, and it broke down. They don't know what's happened inside the spacecraft. I mean, we just lost 2 spacecraft just a couple days ago. People are trying to figure out what happened. Where did they go? They went offline, and they don't know what happened. And it's going to take a while to sort out. Batteries can blow up. They can, then you could have had a space debris impact that took out. It's happened in the past. Antennas on spacecraft, and nobody knew that it happened for quite a while from a space debris hit. So, the precision that the space surveillance people have, it's not, pinpoint accuracy. It's got error bars, between spacecraft that come in close contact in their orbits. So it's, it's not that precise yet. They're trying to get it down, but it's going to take a while. Anyway. There's lots of ways to fool people.
Do we have any sense of how much space debris is out there and how large it is?
Yeah. I don't know what the number is now, but it's huge and it's getting bigger. Again, the tracking capability, I think they're down to 10 centimeters across or something. And some of the new systems can do it even better. But when you think space debris, it's not just large chunks. I mean, some of this is paint chips. One of the stories I wrote about a long time ago, it turns out that some of the old Soviet reactor driven spacecraft are leaking their coolant, which is radioactive. So you have a whole trails of coolant drops floating around out there as well. So no, there's nose cones, there's cameras, there's a toothbrush still up there, I think. I don't know.
Wow.
You know,
A few golf balls, lots of
yeah,
bolts.
yeah.
All this says to me that at some point, the citizens of the world are going to be very upset with all this debris and what damage it can cause to the earth itself.
Yeah.
I mean, it gets
Well-
back to a comment that Ted made earlier, that I think got some of our discussion going in terms of this large satellite going up and what its effect might be.
Yeah.
The thing that Ted was talking about is this thing is very reflective. It's going to be so bright. It's going to be as bright as some of the brighter stars in the sky.
Wow.
And so there's a lot of astronomers that are, it's one thing to see the Space Link or the Starlink train go by, but it's another thing to be blinded by the headlight of the train,
I thought it was more like Venus, and that's a bright thing.
Yeah.
It's pretty bright. Something to answer, you said, Lena, that it happens, space weather happens to the whole Earth. In a way, it doesn't. It really depends on what part of the Earth is pointed toward the sun when space weather arrives. So the far side of the planet will be shielded from anything that blows
Okay.
by it. But if you're on the daytime side, it'll knock out, like space weather knocks out right now. Radio communications were knocked out because there was a solar flare last week. And it was only in like the Caribbean and South America. It was in that area. So it was very localized that it was just happened to be, that's what was pointed at the Earth at that time.
Does it have to be near the equator?
No, not at all. It just happened to be where these outages aren't like worldwide. They're just very localized, and it really depends on what the solar particles are doing to the ionosphere when it hits. So, and that's why we have aurora and things like that. All of it, thank goodness we have a magnetic field. We don't get a lot of this is just funneled up to the poles and then interacts with the atmosphere up there to form the aurora. But there was an event on the sun in the 1860s or the 1850s called the Carrington event, and it was a solar flare of some sort, but we didn't know about solar flares back then, and this was just at the beginning of technology. Like there were telegraph lines that melted in between poles. There was a telegraph line between the United States and Britain that melted because of the power of the solar particles interacting with the magnetic field and with these basic technologies. It also created aurora that were seen as far south as Cuba and Hawaii. There's stories of miners in Colorado who thought it was morning and started to put on coffee, and it was like 1 a.m. So this event was pretty incredible, and they forecast if this kind of event hit the Earth today, it would knock out the power grids of the eastern, whatever is pointed at the sun. At that time, it would knock out the power grid, and it wouldn't come back for like 6 months.
Wow.
It would just totally take it down. This is why there are the Air Force and these other places are so interested in space weather, and why it's such a concern that other countries would use this kind of, I don't know, deception to mess with our things.
But the reality is our communication systems are so intertwined and interrelated worldwide that something that happens to the east coast of the United States will affect Europe, affect other parts of the world.
Well, for sure. And, you know, to be clear, we're safe. Humans, like, it's not going to affect us biologically. It just, whatever happens on the sun interferes with our technological life. So even the satellites in orbit would be prone to being, you know, maybe circuits fried and things like that. And it's one of those interesting things we're studying, right? So, but we are all interconnected. And
Can I ask a very stupid question? I was talking to someone today about the blue zones in about 8 different parts of the world. The blue zones are places where people, a large number of the populations within those zones live beyond the age of 100. And the person I was talking to mentioned that in several of these blue zones, there are magnetic fields like Sedona, Sardinia, Tibet, where literally people live longer, partially because of that magnetic field affects the human body. I don't know. I mean, you all are much more scientific than I am, so I'm asking this silly question.
Are there B&Bs in those locations?
Are there what? B&Bs? Of course.
I was trying to write down where you were talking about.
Sardinia,
I'll go to Sedona anytime.
Sedona, and Tibet.
Oh, man, no, Sedona is great. Yeah,
well,
flying in there is scary. You live longer if you make it.
Well,
You
does
just
anyone
drive.
have an opinion about that? I just, from a more scientific area.
Well, we
I don't-
were married in Sedona, so we hope you're right.
That's great.
well, the magnetic field of the Earth, you know, the Earth is not a perfect sphere. And so it's got bumps and valleys all over it. And the magnetic field does change all over the Earth, the magnetic strength. So I don't know if they line up with these blue zone places, but it's possible.
So John, you mentioned outage of 6 months or more. It could be a lot longer if it depends on how powerful the outage or how extensive the outage is and how many large transformers are, damaged.
Yeah, I wasn't, I don't want to sugarcoat it. It's not going to be good when it happens. So 6 months is pretty conservative.
How often
mean-
has that happened, John, in terms of solar flares?
Well, solar flares happen all the time. They're just not as strong as the Carrington event. Part of it is too, the solar flare was directed, whatever happened in the 1850s, it clearly was, Earth was a direct shot. And it, you know, there's a lot of space. So the
Yeah.
Earth being hit by some piece of, you know, of the material that gets blown off the sun in a coronal mass ejection is pretty low, but it happens all the time. There's there are prominences and there's a lot of material. I mean, it's, you know, when I say material, it's not like it's just very diffuse gas, and a lot of it's mostly magnetic field that comes off the sun. And then I don't want to get too complicated, but it depends also on the magnetic field doesn't come off kind of uniformly. It twists like a liquid. And so it depends on with the alignment of the magnetic field when it hits Earth. You know, how if the magnetic field's aligned, it might not be so bad. If they're opposite, it would be bad. So it's such a moving system. But to answer your question, basically, it happens all the time. We live around an active variable star, so it is what it is.
Yeah.
Along with this, we don't really have replacements for these large transformers. Sorry, I was out of the room for a minute. I don't know if you covered this already, but I have asked people in the power industry, what are you going to do if we have a big solar flare? I don't know. Nobody ever knows. So you would think they'd warn you that they're going to turn the power off for a while, which would help preserve the transformers. But we just had last weekend a big power outage in North
Yeah.
Carolina, where my dad lives, and he was out of power for about 12 hours, but some houses didn't get power back till Thursday, so it was like 5 days, and that was just someone shooting at some small transformers. So they don't have a lot of replacements for these things. It would be, well, how do you even replace a transformer when the whole world is out of power so that you can't build a new transformer? It's kind of silly.
Hopefully Elon Musk has got solar powered, self-contained things to solve.
Well, it's kind of a hell of a way to end the year. It sounds like we're headed into apocalypse.
I'm gonna move back to Colorado.
Yeah, right.
I apologize for asking the question.
Oh, no.
It's led to a long discussion on the apocalypse.
I think it's great to talk about these things.
Well, Barb and I were in, I think New Mexico. I don't know what year that was, but we went up to a gas pump and the gas pump wouldn't take our credit card. And it was really the first time that I ever connected that all those gas pump credit card things go through satellites. And they had a satellite that went down and the whole system went down. And you start magnifying that, okay, credit cards for your gas is one thing, but national security problems, you have, you never mind, I want my MTV, you wouldn't even get it, you wouldn't get anything. And so you interrupt football season and we're really going to be in trouble.
But on a more positive note, I don't know if any of you have been watching the Branson movie on HBO, but we thought it was quite good. There's 4 episodes and there's been 2 of them so far, once a week. I think it was last night that it recorded for us. And it's pretty interesting, just that right now they've sort of gone through Branson with Virgin Airlines. And I guess by the 4th one, I would hope they have his involvement with, space. But it's really pretty positive and really interesting to find out more about how his mom influenced him and his dad too, in a way. And just some that, they went through his balloon experiences and he did some boats across the Atlantic. And he was a real adventurer, as we know.
These films are kind of odd because I think they were made before Branson flew on the Spaceship Two with his other people. Yeah. And I think in total, what this looks like is that if he died, he would have some kind of documentary, thing about him. So there's a little bit of apprehension that he's into. He breaks down, starts crying in one of the first episodes and talking about this mission coming up. He was the most dangerous thing he'd ever done. But it's clear that he was up, kind of hoping that it would all work, and it did. But anyway, the guy's a character. We've seen him in action.
Yeah.
Unbelievable.
Wait, and one other thing I wanted to say, and we can go on with our conversations, but I want to make sure while Clark and Y are still on, that they provided this wonderful spruce tree that you see behind us. They have one too, and we thank you very much for that. It's great to have it for our holiday SkyWatchers. Yeah.
And wood.
And I'm sorry that we couldn't meet in person, and I appreciate, Clark's been keeping me updated on, the cases. I see it too in the news, but yeah, it sounds like some of us older people, we've got a few younger people on here maybe, but that were even vaccinated, were still, the highest risk category, the older people. So we're not going out much. But yeah, I'm just glad we're all still here. And I guess it was kind of crazy to think about having a event right before the holidays too, because you don't want people to get something and then miss out on the holidays. So I'm glad. So I think for January we'll be on Zoom. We'll just kind of monitor it, and hopefully sometime next year we can get together. And Carolyn Collins Peterson isn't on today, I think, because she's doing the Netherland Artists Bazaar thing there. But I think she's, when the weather gets good again, I think she's going to try to have some star parties there in Gilpin County too. At least those are outside, so a little more better. But yeah, does anyone else have anything they want to share? And let's see.
I'll try to lighten the mood a little bit after I ask that question. So
Yeah.
I just gave you a link to a balloon's path around the Earth. It's just about 4 times around the Earth now. It was back in the middle of October, like 17th or something, when it launched from near Phoenix. And so it's just at 40,000 feet, just floating along, following the weather. I think it's kind of fun to watch.
Huh. Wow. What kind of instruments? I mean, what is it trying to do?
It has a ham radio call sign, NU7B, and there was a 21 balloon or a 20 balloon, and so this is 21 balloon. And I can't find out much information about it, but I learned about it just after it took off back in October, I think. And everyone was surprised it made it as far as South Carolina. Well, that's a long time ago, and it just keeps looping around, going past Egypt and China all the time. It's fun to watch.
Wow, that's great.
Yeah, and you said, how do we access that? You had that.
So I gave you the link. You'll click on it, and you get a world map and where it's been the last 7 days.
That's great.
Okay, great.
So Leonard, I got a question. At one of the previous meetings about 3 years ago, maybe 4 years ago, Stuart Walker was there. Didn't he work on the Orion capsule?
Yeah, we were talking about him and maybe seeing if he or someone from, maybe he and someone else too, from Lockheed Martin, maybe could do our January presentation.
Yeah.
Leonard was saying maybe if it lands safely tomorrow, but even if it doesn't, it would be good to have, and then they can tell us why. Hopefully it wasn't his fault. But yeah, we got that up. Yeah, we're looking at that.
I heard an interesting
Really gonna
thing.
pick up this lunar exploration thing. I mean, I think somebody mentioned in SpaceX, if it goes tomorrow on that vehicle, are 2 lunar-bound spacecraft. One's a NASA CubeSat called Lunar Flashlight, and it's going to hopefully look for ice at on the moon. And there's also a private Japanese lunar lander, and that's on there as well. So that's 2 moon-bound spacecraft. We just got Capstone, looks like safely in a certain type of orbit that it was shooting for. That was a CubeSat as well, built by Advanced Space over in Westminster, or run by them. And what else has happened?
What, and is that this one?
There's a bunch of robotic spacecraft.
Is
Well,
it this one? This one.
yeah,
Okay, so that's launching tonight at 12:38 our time. You know, the SpaceX launch of the flashlight.
really.
Yeah, and
Okay.
Hakuto?
The PM, sure.
Well, it says that AM, so
Oh, AM.
for Eastern,
Wow.
yeah.
Okay.
So yeah, 12:38,
Yeah.
and so that's on spacex.com. Usually just bring that up at what, 10-15 minutes before the launch.
Yeah.
or something.
But I think the really exciting thing about the moon now is we've got a lot of CubeSats going to go along with the human missions, and the moon's going to surprise us. I think once we get back down there with the right kind of new instruments, there's some surprises coming. So it's really a fascinating time. The School of Mines over here, they got a whole mining operation ready to go for the moon. So they're ready, they're trying to understand, what's the best extraction and processing you can do with lunar material. And that all feeds into the possibility of using local resources on the moon to sustain human life and build structure and, build equipment, and even on the far side, looking at a deep space, either some kind of Arecibo-like far side radio telescope would be terrific, shielded from the Earth. But the moon is going to be peppered by either new craters by people trying to land on it with private rockets and spacecraft. So this year coming up is just a tremendous amount of activity. Pretty impressive by a lot of countries.
I heard an interesting thing about the Orion reentry that's happening tomorrow. You may recall in the Apollo days, they made a big deal about the command module had to hit this narrow window coming in. If it was too shallow, it would skip off the atmosphere. If it was too deep, it would burrow in. Well, apparently Orion, they're actually doing a bit of a skip. And then it's going to come in down to about 60 kilometers and then rise up to about 90 and then come in. And they'll do that because it'll reduce the gravitation, the G-forces on the crew coming in. So I thought that was an interesting development that they've changed the way they do re-entry from the moon now.
Yeah, well, and that's going to be part of the test. Pretty exciting. It's going to be a new development. It also, I think I hooked it up with. I think it makes return from the moon a lot easier because if they use that skip trajectory, by more and more crews coming back. So people forget that one thing, China uses skip. They've used that skip technique on a returning lunar craft that they did a few years ago. The Soviet Union actually used in their circumlunar sound program. They used skip reentry, and these are much smaller, vehicles coming in compared to the Orion. But it's a technique that's kind of proven, but now we got to prove it with potential for human.
Didn't realize it had been around that much.
Yeah.
First I'd heard of it.
Yeah. Yeah, the Sound program, way back, we're talking 70s something. But the Soviets used it then, and then China had a test module that they launched and did a circumlunar and came back at high speed to test their reentry capability and used the skip technique. So it's pretty exciting.
Yeah. Yeah, and you're right that that SpaceX launch is 12:38 a.m. And maybe I said p.m.
I don't know. what-
Anyway, tonight, just after midnight.
Okay, we gotta
Yeah.
stay up now. Oh, God.
Yeah. Oh, God.
Although somebody said it's 60% clouds or something.
Oh, Mike.
I don't know, we
And,
gotta
and
check.
the next available launch is about the same time on Sunday.
Yeah.
Let's hope it doesn't hit the capsule coming. That's a different one.
Yeah, they're gonna land off, Ryan lands, I guess I mentioned that, Pacific, Ocean off San Diego. So this is, and they've got not like the old days with an armada of Navy ships. They basically got one big ship out there, and then it's gonna let a lot of little, other, waterborne vehicles go to the capsule and hook it up for pulling it out of the ocean. So it's really just another step, forward.
Yeah. Okay. Well, I guess our host departed.
Yeah.
I think he
Everything
turned it
worked.
over to me.
Yeah, I saw a notice earlier that said Barbara's out the host.
Oh, okay.
Time to go, time to go.
Yeah, we should
Yeah, we
go.
gotta go,
Yeah.
get ready for the next launch.
Goodbye, everyone.
See you. Yeah, thanks everyone
Right.
for, we know people are busy this time of year, so glad we had 17 people on there. That was great. And if anyone wants to stay on longer, you're welcome to do that and chat.
I think I'll head off and eat.
Bye,
Yeah,
Dave.
I gotta eat.
We ate all our
Okay.
chocolate chips, so. Gotta eat
Bye,
some
everybody.
of us.
Thanks
Yeah,
for
Right.
putting on a nice show.
yeah.
Happy New Year.
Yeah,
Yeah.
Happy holidays.
yeah,
Yeah,
Happy
holidays.
solstice.
Watch out for those storms.
all right,
Keep the solar storms ready.
Yeah.
bye,
Bye-bye. Thanks so much.
yep.
You all. See
No, you
ya.
hang up.
Yeah. I
All right.
gotta be back further, so I don't look quite as old as I really am.
3, 2, 1. There we go.
Okay, bye-bye.
Bye-bye.